This is lesson 90 on measured turns. A couple basic pieces of information that you're going to be applying. When it comes to measured turns, they're actually thinking in terms of like a circle. So a good comparison would be a clock, like the clock that's on the wall in our classroom. You would consider, like if you're standing at the center, looking upward, turning towards the 15-minute mark would be a 90-degree turn. Turning towards the half-hour mark down here, that would be 180 degrees, like that, assuming you're turning to the right, just to get you started. Now, if you turn the other direction to the left, the measurements would work the same way. You'd have 90 here, and then 180 down at the bottom. So again, if you turn left. The left turn is called counterclockwise. The right turn is clockwise. And you can see where the name comes from. Now let's go ahead and apply this to problem number 1. It says Fred is driving north towards the stop sign. Now I suggest you draw yourself a picture as you go through this, and you do it sentence by sentence. So Fred, driving north. North is always towards the top, and he's at a stop sign. Second sentence, I'll use a different color. It says, at the stop sign, he makes a 90-degree right turn. So that means he's turning clockwise. So now he's facing to the right. Next sentence. When he reaches the next block or the next street, he turns 90 degrees right again. All right? So he's going to the next block over, and he's making a right-hand turn. So he's facing down. So he's facing towards the south. Next sentence, he travels 2 blocks. So we don't know how big the blocks are. I'm just going to assume it's twice as long. And he turns 90 degrees left. Okay, so down here, and then another bit. Now be a little careful on this part. Remember, he's facing down. So he's facing to the south. That means his left is right over here. You have to be careful not to use your left and right. You have to use what Fred's would be based upon the direction he's facing. So he's actually going to end up facing to the east. Now the reason why I know that is east is directions go north to the top, south to the bottom, east to the right, west to the left. That's a consistent format that's used pretty much all over the place. You'll see that in your geography book, for example. You'll see that on any map. Number 2, we got Jack and Francis are running in opposite directions. Now it doesn't say that they start at the same spot, and it doesn't say whether or not they start at the same time. It doesn't say who's farther away either. All I know is they're going opposite ways. So let me put Francis going to the right. And Jack, I'm going to have him going to my left. Okay? I don't know that Francis is going to the east. I don't know that Jack is going to the west. I'm just kind of putting out a general plan to begin with. So Jack is over here. The next sentence says, how many degrees must Jack turn to be running the same direction as Francis? All right. So it doesn't say if I have to turn him right or to his left. Now Jack's left-handed, so we're going to turn him to his left. So if he's facing where my dash is to begin with, and I want to turn him, I'd have to turn him 90 degrees down, and then another 90 degrees, taking him back over here. So that would make 180 degrees. So Jack had to turn 180 degrees. Number 3, I'm not going to do number 4. I'm just going to pull that one out. Number 3, Jack and Frances are both facing south. Okay. That's my first sentence. Now remember, south is towards the bottom. We're going to let this one be Jack. And I don't know that they're still moving either, so let me go ahead and put a little dot on that. So this one's going to be Jack. And this one here is going to be Frances. And by the way, I don't know if you can hear her, but she's barking in the background. If Frances turns 90 degrees counterclockwise. Okay, now let's think about this. Counterclockwise goes this direction. Clockwise goes the other way. So counterclockwise, she's turning towards her. She's turning like this. Okay? How many degrees clockwise must Jack turn to be facing the same direction? Okay. So let's get this straight. She's turning 90 degrees counterclockwise. So she's going to end up facing to the east. So we need Jack facing east, but he needs to go this way. So he has to make a 90. This is a 90 here. Then he has to go up. That's another 90. Then he has to go again. That's another 90. So altogether, he has to turn 270 degrees. All done.